when you walk into a laboratory for the first time. There are many chemicals and solutions that you need to work with. These solutions are not immediately ready to use but need to be diluted for your specific application to a set final concentration. We often assume that all scientists can do these calculations, and therefore these skills are not explicitly taught. It is important that you know how to prepare these solutions yourself, so we will walk through a series of exercises on converting concentration measurements and preparing dilutions to different final concentrations. Concentrations can be given in several different ways. The most common include molar concentration, and you will encounter concentrations given as moles per liter, or molar, or millimolar, micromolar, nanomolar, and picomolar. Mass per unit volume, such as grams per liter, milligrams per milliliter, micrograms per milliliter. Percentage or weight per volume. This is written as percentage, weight / volume. A solution listed as 1% weight per volume means 1 gram in 100 mils final volume. Percentage or volume per volume. This is written as percentage, volume / volume, and is used when diluting one liquid in another, for example ethanol in water. A 1% volume per volume solution of ethanol means 1 ml of ethanol in a total of 100 mils, that is immersed in 99 mils of water. A common mistake that people overlook is that solids do take up volume when dissolved in the solvent. If you need to make up 100 milliliters of 2.5 molar sodium chloride, do not weigh out the sodium chloride, then add 100 mils of water. You will need to dissolve the sodium chloride in a lesser volume, and then when it is dissolved, make it up to 100 mils in a measuring cylinder. Let's start with some basic calculations for making solutions. A good tip is to include all the units in your calculations and cancel them out when you're multiplying or dividing. For example, write molar as moles per liter and assign the molecular weight the unit of grams per mole. Then make sure your final answer ends up with the right units. This is easier than trying to remember formula for working out these problems. Let's work through the first example. You are asked to make 250 milliliters of 2.5 molar sodium chloride, and the molecular weight of sodium chloride is 58.44. You can rewrite this as 0.25 liters times 2.5 moles per liter times 58.44 grams per mole. The liter and mole cancel each other out and you're left with 36.525 grams. In the second example, you need to work out the molar concentration of 5 milligrams per milliliter sodium chloride. You can rewrite this as 5 grams per liter divided by 58.44 grams per mole, and this time the grams cancel out. The resulting answer is 0.0856 moles per liter or 0.0856 molar. You can express this as millimolar if you wish so that the value is easy to work with. We multiply by 1000 to arrive at 85.6 millimolar as the final concentration. Now, let's talk through how dilutions of solutions are typically calculated. The formula that is commonly used is C1 times V1 equals C2 times V2, where C1 and V1 refer to the concentration and volume before the dilution, and C2 and V2 refer to the concentration and volume after the dilution. Another way to think about this is by using dilution factor. The dilution factor is the final concentration divided by the original concentration, which is equal to the starting volume divided by the final volume. This is just rearranging C1 times V1 equals C2 times V2 into C2 divided by C1 equals V1 divided by V2. Let's work through some examples. You have a stock of 2 milligrams per milliliter LPS and you want to dilute this to 2 micrograms per mil and obtain 10 milliliters of this solution. How much of the stock do you add into 10 milliliters? Step 1. Find the dilution factor using C2 divided by C1 equals V1 divided by V2. C2 is 2 micrograms per mil and C1 is 2000 micrograms per mil. Always make sure the units are the same. 2 divided by 2000 equals 1 by 1000, which we refer to as 1 in 1000. Step 2. Multiply the dilution factor by the final volume you want. 1 in 1000 times the final volume of 10 milliliters equals 0.01 mil. This is how much stock you need to add into 10 mil. In the next example, you've added 20 microliters of a 2 milligram per milliliter solution of DNA into 5 milliliters of water. What is the new concentration? Step 1. We first calculate the dilution factor. C2 is 0.02 mil, normalizing the units of 20 microliters into milliliters, and C1 is 5 mil. C2 divided by C1 equals 0.004. Step 2, we multiply the dilution factor by the original concentration. The dilution factor is 0.004 from the previous step, and we multiply by 2 milligrams per milliliter. The answer is 0.008 milligrams per mil, which we can multiply by 1000 to express as 8 micrograms per milliliter. These calculations will either seem very simple or very confusing depending on your previous experiences. It will be interesting to go back over an old experiment you have performed and figure out how the solutions you used needed to be diluted from the original concentration. Hopefully this is helpful, and feel free to work through these examples again at your own pace.